You are about to see a photograph of a real, healthy baby, born in a hospital, perfectly normal in every way, except for one thing. Growing from the base of its spine is a small, soft tail. Not a metaphor, not a birth defect in the usual sense, a tail. And every doctor in that delivery room knew exactly what it was. Evolution running a memory it forgot to delete. I'm Dr. James, and today we are going inside your body to find the parts of you that no longer belong to you. Organs, muscles, bones, and reflexes that are still showing up to work every single day, doing jobs that stopped mattering millions of years ago. These are called vestigial structures, and they are one of the most powerful proofs of where you actually came from. Let's start at the very bottom. Literally. Right now, at the base of your spine, you have a small cluster of fused bones. It's called the coccyx, from the Greek word for cuckoo, because early anatomists thought it looked like a bird's beak. Most people call it the tailbone, and if you've ever fallen hard on it, you know it is very real and very sensitive. The reason it hurts so much? Muscles actually attach to it. The gluteus maximus, your largest muscle, partially anchors there. The pelvic floor, which supports your bladder and intestines, connects there too. Your tailbone is genuinely load-bearing. It just doesn't serve the original purpose it was designed for. Because the original purpose was a tail. In our primate ancestors, the ones who lived tens of millions of years before modern humans emerged, tails were essential. They were used for balance when running across uneven terrain, for gripping branches, for signaling mood and status to other members of the group. As our lineage began walking upright and spending less time in trees, the tail became unnecessary. Over millions of generations, it shortened, vertebrae fused together. It retreated inside the body, and what remains is the coccyx, the ghost of a tail, encoded permanently into your skeleton. Now here is where it gets truly remarkable. Every human embryo between the 4th and 8th week of development grows a real tail, a real one, longer than the embryo's legs at that stage. It contains the same structural elements, muscle cells, nerve fibers, the correct number of vertebrae for a tail. And then, right on schedule, a biological process called apoptosis, programmed cell death, dissolves it back into the body. The tail is absorbed before birth, in the vast majority of cases. But sometimes the signal doesn't arrive. The apoptosis program is delayed or simply doesn't fire, and the baby is born with the tail still there. This is called an atavism, from the Latin word for ancestor. It happens in roughly 1 in every 100,000 births worldwide. It's soft, covered in normal skin, and can be up to 5 inches long. It contains fat and muscle. Some reported cases showed it could even move. Surgeons remove it shortly after birth. The child is completely healthy, but that tail, it's your body briefly remembering something ancient. This is not the only place evolution left its handwriting on you. Reach your arm out in front of you, palm up. Bring your thumb and pinky together. Now flex. Do you see a raised tendon running up the center of your forearm? About 15% of people reading this right now have no tendon there at all. They are missing a muscle called the palmaris longus. Gone, vanished, not from injury, from evolution. And the people without it suffer absolutely zero consequence, no weakness, no loss of grip, which tells you exactly how useless that muscle has become. It helped our tree-climbing ancestors, as we explored in our episode on the palmaris longus muscle, grip branches with a power grip. We don't climb trees anymore. The muscle is leaving. And it's taking its time about it. Look at the corner of your eye, right at the inner edge where your upper and lower eyelid meet. You'll see a small pink fold of tissue. Doctors call it the plica semilunaris. Most people assume it's just a tear duct structure. It isn't. It's the remnant of a third eyelid, the nictitating membrane. Sharks have one, cats have one. Birds use theirs constantly, sweeping across the eyeball to clear debris while keeping vision uninterrupted. You have the base of one, just enough left to remind you that your genome once built that structure completely. Now think about the last time you were cold or frightened and felt that wave of goosebumps rise across your skin. Tiny muscles under each hair follicle, called erector pili, contracted. They were pulling on hairs that you no longer have in meaningful amounts. In a furry mammal, that same reflex fluffs the coat up, trapping warm air, making the animal look larger to a predator. In you, it produces a visual that communicates roughly nothing and keeps you exactly no warmer. The reflex works perfectly. The hardware it was built for is just gone. Then there is the pyramidalis muscle. Do you have one? You probably don't know. It lives inside your lower abdomen, a tiny triangular strip of muscle that sits just in front of the rectus abdominis. About 20% of people are born without it entirely. The ones who have it can't feel it working. It creates mild tension in a sheet of connective tissue called the linea alba. What that actually accomplishes in modern humans is genuinely unclear. Kangaroos use theirs to move the pouch. Humans kept the muscle, but apparently not the purpose. Let's talk about your wisdom teeth, the third molars that erupt, when they erupt at all, between ages 17 and 25 and immediately cause problems for most of the people who grow them. Impaction, infection, pain, misalignment. Dentists remove around 10 million of them every year in the United States alone. They are vestigial chewing structures. Our ancestors had larger jaws to accommodate raw, tough vegetation and meat. As our diet cooked and softened over thousands of years, and as cooking itself allowed our faces to become smaller and our brains to become larger, the jaw shrank. The teeth didn't get the message. They still arrive. They just don't fit. And here is something even most doctors overlook: your ear muscles. You have 3 muscles attached to each of your ears: the auricularis anterior, the auricularis superior, and the auricularis posterior. In most mammals, these muscles do precise, continuous work. A dog swivels its ear like a satellite dish to track a sound. A horse flicks them to signal attention or fear. Your muscles are still physically present and still receive nerve signals from your brain. About 10 to 15% of humans can train themselves to wiggle their ears a little. The rest cannot produce meaningful movement at all. But the muscles are there, contracting slightly, achieving nothing, waiting for the command to do a job that was never passed down to them. When you step back and look at all these structures together, the coccyx, the plica, the erector pili, the palmaris longus, the pyramidalis, the ear muscles, the wisdom teeth, you start to see not a collection of random anatomical details. You see a timeline. You see a body that was not designed from scratch, a body that was built on top of and repurposed from blueprints that go back hundreds of millions of years. Evolution doesn't start over. It edits, it patches, it leaves behind obsolete code that mostly runs silently in the background. And occasionally, once in 100,000 births, it sends a message from the past that is just a little too loud to ignore. That is your coccyx telling you who you used to be. If this episode made you rethink something about your own body, hit like and subscribe. There is so much more of this story left to tell.